Welcome back. This is episode number 5 of this tutorial series / crash course on ROS2. You can find the series playlist in the description. And let's get started. Now let's write our first node. This will be kind of a hello world node so that you can get familiar with how to write your own nodes, how to start it, and how to use the command line tools to introspect the node. And after this node, we are gonna start our turtle controller project. So where to create a node? Let's go back to our ROS2 workspace. Here in the source folder, we have my robot controller package. So we go inside the package. And now, well, this package is actually a Python package. So we have specified that when we created the package. So we are going to go in the folder which name is the same as the package name. So let's go to my robot controller. Okay, so we are in my robot controller, in the source of ROS2 workspace. This one will contain only init.py. We just leave this here. And we are going to create a new Python file with touch. Let's call this my first node.py. We just create a file like this, okay? And let's make it executable with chmod +x, my first node. So now it should be green here in Ubuntu terminal. All right, so that's the first step, is to create a Python file and make it executable. Then let's go back to our source folder of the workspace and let's open Visual Studio Code here. So I'm gonna do code dot. Okay, and we are in my robot controller package. So we are in the source here, the source folder, and we have my robot controller. We have just one package for now. If I open this and if I open this one, I will see my first node.py and I can start to edit the file. So let's add the interpreter line. So like this, user bin env python 3. Okay, so that's interpreter line to tell the interpreter to use Python 3. And then I am going to import rclpy. Okay, rclpy is the Python library for ROS2. So we will need to import it every time we want to create a ROS2 node with Python. Now the thing is that, well, you can see rclpy is not recognized. We don't have autocompletion. So if we want to have autocompletion with Visual Studio Code and have some nice functionalities on top of that, we can go, so let's just save the file here and we can go to this here, extensions. And I am going to search for the ROS extension. So it says, do you want to install Python? Let's just ignore that for now. And let's search for ROS and find the one with the Microsoft, okay? So the ROS extension will actually work for ROS1 and for ROS2. Okay, and that's the one we're gonna install. So let's click on install. Okay, and now it should be good. So let's go back actually to the extensions and let's see what we have installed. So as you can see, now we have different extensions that are installed. So we have ROS, we also have Python, okay, which was installed with the ROS1, okay? We also have C++, so if you want to write code with Visual Studio Code and do Python and C++, you just install the ROS extension that's gonna install Python, C++, and everything you need. So now we don't need to worry about it anymore. So you can see now rclpy is recognized and we will have autocompletion for all the features in rclpy. Great, and maybe you need to restart VS Code, depends. Here I don't need to, so I'm just gonna continue like this. Now what I will do is I will create a main function. So def main, and I'm gonna put args is equal to none. So I'm gonna allow this main function to receive some arguments, and by default I put them to none. Okay, let's just put pass for now. We're gonna fill this function later, and then let's do if name is equal to main, and let's call the main function. Okay, so this is gonna be useful when we want to directly execute the file from the terminal, for example, by just running the Python script. And having a main function just like that will be useful when we want to install the node with ROS2 functionalities. So what do we want to do in the main function? Well, the first thing to do is to initialize ROS2 communications. So to do that, we do rcl py.init, and like that. We can pass args is equal to args. So the args parameter of the init function equal the args that we get from the main. And so this is going to be the first line in your main. We initialize rcl py, or basically we initialize ROS2 communications. The last line is going to be rcl py.shutdown. All right, and everything you will write will be actually here. So first line rcl py.init, last line rcl py.shutdown, so that you start ROS2 communications and you shut down ROS2 communications. And in between, we will be able to create a node. So the node is actually not the file itself, is actually not the program itself. The node will be created inside the program. And so for now, of course, we're going to create just one node per program. But as you get more advanced with ROS2, you will see that you can actually run multiple nodes from within the same program. All right, so let's just start with the first node now. And actually, in ROS2, the way to create nodes is to use object-oriented programming. So we are going to create the node actually outside of the main here. We are going to create a class. And this class will actually inherit from the node class of rcl py. So we will need to do from rcl py.node import node, and then we can create, let's say, my node. So that's going to be the name of the class, open close parentheses, and we put node and then colon. So by doing this, we define a class my node which inherits from the node that is from rcl py.node. Why we do this? So that our class can already have access to all the functionalities of ROS2. Now in this class, the first thing to do is to create a constructor. So def init like this with self. And the first line in the constructor is going to be super. Okay, we're going to call the constructor of the upper class, so the constructor of the node class here. So super open close parentheses dot init open close parentheses, and here we are going to provide the node name that we want to have. So this one is the node class, okay, it's just for programmatical purpose. That's the node class we're going to use in the program, but this is the node's name that's going to be used when we actually run the node in the graph. Okay, so let's call it, let's say, first node. Okay, I'm using on purpose, I'm using a different name for the node's name and the file's name, okay, just to show you as an example, and I'm going to come back to this just a bit later. So by doing this, we have initialized the node, and that's the minimum you need to do to create a node. Create a class, a constructor, you call super, and you give the node's name. Now let's go back to our main here. So what do we want to do? Well, just after we initialize ROS2 communications, let's actually create the node. So let's just do node is equal to my node, and well, in the constructor, we don't have any parameters, so nothing in the parentheses here. You can add as many parameters. You can just do whatever you want. Okay, that's a class, so you can customize it as you want. But for now, we have nothing, just self. Okay, so we do node is equal to my node, and then we have created the node inside the main. So what's going to happen here? We initialize ROS2 communications and ROS2 features. We create a node that's actually inherited from the node class of rcl py. And then, well, we're gonna run some stuff, and then at the end, rcl py.shutdown, which is gonna also destroy the node and everything inside the node, and shut down all ROS2 communications. Now I am going to come back to this constructor, and I'm just gonna add one line so that the node can actually do something, because if we run like this, nothing's gonna happen. So let's do self.getLogger. Okay, so self will actually get the functionalities of the node class. Okay, so inside this we have getLogger dot, let's say, info, and then let's say hello from ROS2. All right, so that's the way to write a log with ROS2. From within a class, you do self.getLogger.info and some text Let's save this. And now let's go back to the terminal. Maybe on that one, let's go to ROS2 workspace, source, my robot controller. We have the file, let's run it. My first node. Okay, you can see, hello from ROS2. We have a log with info level, the timestamp. First node is the name of the node as defined here. Okay, and then we have hello from ROS2. All right, so that's working, and we have run our first node. Okay, so actually what we have run is a Python script that we have set as an executable. So we have run a Python executable, and in that executable, we initialize ROS2, we create a node, we do stuff with the node, and then we shut down ROS2. Now, as you can see, when I run the node, we have something printed, and then we directly exit from the node. But if you remember, when we have started a few nodes previously, well, the node was continuously running, and we had to press Ctrl+C to kill the node. Here, once again, you can see the node directly exits. So what I'm gonna do, I'm gonna add, after creating the node, and of course before the shutdown, I'm going to do rclpy.spin and pass the node as a parameter. Okay, what is that? So what is the spin functionality in ROS2? Well, when you make a node spin, basically what it means is that this node is gonna be kept alive. So it's gonna continue to run indefinitely until you actually kill it with Ctrl+C, for example. And while it is alive, all the callbacks of the node, so we're gonna see later how to create callbacks for the node. So all the callbacks will be able to be run. So basically, we keep the node alive so that it can continue to run and to communicate with ROS2 functionalities until we want to kill the node. And when we kill the node with Ctrl+C, this is gonna return, and then we can do rclpy shutdown, which is gonna destroy the node here, the class and everything, and shut down ROS2 communication. So let's save this and let's go back to the terminal. Let's run it again. You can see hello from ROS2, but now we are still, you can see the node is still running. Okay, I can press enter. We are still in the node. Now I press Ctrl+C and you can see the node is killed. So we have this exception, which is not really a problem, okay? Don't worry about this, about the keyboard interrupt. It's not a problem. But you can see here that now the node is alive. And we have to kill it with Ctrl+C so that it stops. All right, let's come back to the node. Now, well, we have run the node from the terminal as a Python script, but that's not what you want to do later. What you want to do is to be able to run it with the ROS2 functionalities, for example, with ROS2 run, like we have seen before. So how to do that? We will need to, well, actually to install the node. How to install the node? Well, that's very easy. You go to setup.py of your package. Okay, so my first node is in this package. I'm gonna go to the setup.py. In setup.py here, I have entry points with console scripts. I'm gonna go inside the array of console script, press enter, add some quotes, and now what I will do is I will create an executable name. Okay, so for example, test node, and then is equal to, I will need to put my robot controller, so package name dot file name, my first node without the Python extension, and then colon main, which is actually the function we want to run. So if I go here, I have a main function. That's the one I'm gonna provide here. Okay, so test node, this is going to become the ROS2 executable, is equal to package.filename colon function we want to run. I am saving with Ctrl+S, and now let's go back to the terminal. And we are in our ROS2 workspace. In the source folder, I'm gonna come back to the ROS2 workspace here, where we have the build, install, log, and source, and I'm going to do callcon build. Let's press enter. Okay, and you can see now the package has been built. And now this is very important. After you have built the package, if you want to use new functionalities that you have developed in the package, you need to source your environment again. Okay, you need to source your workspace. How to source the workspace? You can do source bash rc, because all the source lines have been put in the bash rc. So source bash rc. Okay, and now we can do ROS2 run my, so let's use auto-completion, my robot controller. If I press tab here, we have test node. So as you can see, my robot controller, this is the package, test node, this is the node that we have created. I press enter, and you can see we have the node here, hello from ROS2, still alive, and now I can press Ctrl C to kill the node. And so now I'm going to come back to the names here that are very important. So my robot controller, well, this is the package name. But then you can see we have test node here. We have used test node, which is the ROS2 executable. Then we have the file name, which I have named my first node. Okay, and we have the node's name, which is first node. Okay, so make sure you make the difference between the three. We have the node's name inside ROS functionalities. We have the file name where you're gonna write your code. And we have the executable name, which is the one that's gonna be installed with callback build, and the one that you are gonna run. Okay, you can see here test node with the command line tool. Okay, so executable name, and then file name, and then node name. Three different things. If you want, you can use the same name for all of them, for the executable, the file name, and the node name. Okay, that's what I'm gonna use in the future actually. But here I am making it different so that you can see that there are three different things. And now a quick tip I'm gonna show you that's gonna help you to develop faster with Python. So the thing is, every time you're gonna change your Python code, you will need to actually build again, okay, with callback build, and then you will be able to run the updated version of the node. But with Python, you know that actually Python is an interpreted language. So that would be nice if we could actually skip the building part when we want to run a new version of the Python script. And how to do that? So let's first I'm gonna just change the log here. Okay, just print ROS2, just to show you. Let's go back to the terminal. And now if I run the node again, well, you can see we have hello from ROS2. So this is still the old version. Okay, you can see now the code says ROS2, but we are still having hello from ROS2. So how to fix that? Let's do clear here. I am still in the ROS2 workspace. I can do callback build with symlink install. So -- symlink install. And you can see I can have the auto completion. So if you don't have the auto completion, make sure that you have correctly followed the installation steps when we created the ROS2 workspace. When I do this, okay, let's source the bash rc. Now let's do ROS2 run my robot controller with test node. Okay, we have ROS2, which is, well, quite expected because anyway we have built the package again. But now I'm gonna just remove the 2, for example. I save, and now let's run again, and you can see we have ROS. So we had ROS2, now we have ROS. We haven't built the package again, but because of the symlink install option, what's gonna happen is that you will be able to directly execute the new version of your script without having to install it or to build it every time. All right, so that's quite convenient. And note that if you have some errors here, maybe you will also need to source. So when you want to modify the script, after you modify the script, you also source the bash rc and then run the node, okay? Just in case if you have any problem. All right, now let's come back to the node, and actually let's make this a bit more interesting. So this node for now does, well, pretty much nothing. It just prints something and that's it, and then wait with the spin. I'm going to create a very common structure that we are going to use in the following of this crash course, and that you are going to use also all the time. So what we want to do here, let's say we want to print a message every second. For that, we are going to use a ROS2 timer and a ROS2 callback. So the principle is simple. We create a timer inside the node that's gonna say every 1 second, I'm gonna call this function, and this function is gonna do something. So let's create actually def timer callback with self. Okay, so we create a timer callback inside the node. Okay, very important, inside the node with the correct indentation. And here we do self get logger, and let's say hello. So nothing very special, we just create a function that prints hello. So actually not get logger hello, but get logger dot info with hello. And here, well, let's remove this line and let's do self dot create timer. Okay, so you have another function inside the node that is create timer. Now you need to give a timer period in seconds, and that's a float number, so let's do 1.0, and then a callback, self.timer callback, without the parentheses. Okay, here, just the name of the function. And that's pretty much it. Let's just run this, so save and run. Let's see what it does. Hello, you can see hello, 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 etc. Every 1 second, you have hello. So what happened here is that, well, we first initialize ROS2 and then we create a node in the constructor. So we set up the node with a name. We create a timer that's gonna call the timer callback every 1 second. So until now, nothing happens, but then we call lclpy.spin with the node. So the node is gonna be kept alive, and spin actually will enable all the callbacks for the node. So that's where it is super important, is that this timer is a ROS2 functionality that's gonna call a callback. This callback will be enabled because of the spin. So the spin will make sure that this node will execute all its callbacks, and so every second this is gonna be called, and we can print hello. We can also, so let's say for example we add here self.counter. I'm gonna use underscore at the end for attributes of the class is equal to, let's put 0, and then let's put hello plus str.self counter, like that. So we're gonna print the counter and then do self.counter plus 1. Okay, so the idea is to print hello 0, hello 1, etc. I save, let's run again. Okay, hello 0, hello 1, hello 2, hello 3, etc. Well, now let's run it again, and let's run here, let's do clear, let's run RQT graph. Okay, let's refresh. You can see now we have first node. Okay, that's the node that we have actually defined here. This is the first node that's running. Okay, so we can see it with RQT graph. And for now, well, there is just one node, there is nothing else, and this node is not communicating with any other node, so that's just one node here. And I'm going to show you another command, because you have seen the ROS2 run command to start a node, but then you can also use, so let's do cd here, you can also use ROS2 Node. So the ROS2 Node command will allow you to introspect your nodes. You can do ROS2 Node list. You can see I have first node. You can do ROS2 Node info with the name of the node. Okay, that's gonna give you some information that we're gonna see actually later. All right, you have now created your first node and used a few of the most important ROS2 functionalities, such as logging, timers, callbacks, spin, etc. You can also start your node and introspect your ROS graph. All right, that's the end of this episode. If you found it useful, you will definitely like my full course on ROS2 for beginners. This course contains more than 10 hours of content and will teach you everything you need to create complete ROS2 applications. You can find the link in the description. Thank you for watching, see you in the course or in the next tutorial of the series.